There's been a murder. The victim, your common sense. The killer's been loose for 400 years, and you live at the crime scene. You thought physics was equations invented to ruin your Friday. It's not. It's a 400-year murder mystery with 7 crime scenes. The whole plot in one sentence. Physics is a detective hunting the fewest rules that explain the most stuff. And it keeps winning. Why the apple falls. Why coffee goes cold. Why the sun shines. Perfect record. And yet, it still can't explain 95% of what you see. We'll get there. But every rulebook does the same creepy thing. It works flawlessly, right up to one weird spot where it just breaks. And that crack isn't the end of physics. It's the door to the next physics. So forget memorizing. Follow the cracks. Meet our volunteer. We're walking this little guy through all of physics, in one sitting, breaking him a brand new way at every crack. He has not been told this. Rulebook 1. First detective, Isaac Newton, 1687. The guy basically invented the genre. Your gut says things stop on their own. Newton says, nope, watch a puck on ice. Stuff keeps moving until something pushes it. The universe forgot to install brakes. It's called inertia. Why your coffee lurches forward when the bus stops. The coffee didn't get the memo. Newton's headline rule, F equals ma. A push doesn't set how fast a thing goes. It sets how fast its speed changes. And the heavier it is, the more push you need to change its speed by the same amount. Mass is just how stubborn something is. His second gift, gravity. Every chunk of mass pulls every other chunk. The same rule that yanks the apple down holds the moon up. One rule, 2 jobs, and it's an inverse square law. Double the distance and the pull doesn't halve. It drops to a quarter. Geometry is brutal. So why doesn't the moon fall on us? It is falling. It just keeps missing. Fling it sideways fast enough and it falls around the Earth forever. That's an orbit. Now the party trick. A feather and a bowling ball drop together, hit the floor at the same time. Same time. Heavy stuff gets pulled harder, but it's also harder to move. The two effects cancel exactly. Weight has nothing to do with it. Air is the only liar in the room. In 1971, an astronaut dropped a hammer and a feather on the moon live on TV. They landed together. Okay, volunteer's turn. Frictionless ice. He decides to get rid of a boulder by shoving it. Third law, every push pushes back on the other object. The boulder goes one way, our guy goes the other. That's how rockets and walking work. And on frictionless ice, he never stops. He's still going. Wave goodbye. Quick mythbuster. Your mass, how hard you are to shove, is the same everywhere. Your weight is just gravity's grip. So you're not heavy. You're standing on the wrong planet. On the moon, you'd weigh a 1/6 as much. Same body, lighter bill. And Newton's rulebook works. It flies every spacecraft we've ever launched. Perfect, not so far. Newton tells you how things shove each other, moment to moment. He never tells you why you can't shove for free, why the universe always keeps a perfect total of something. That something is energy. Energy is the universe's money. The weird part, you can never make it or destroy it. You only watch it change disguises, lift your mug. Your muscles pay a fee to give it height, stored potential energy. The higher you lift, the bigger the deposit. Let go, and the fee gets refunded as speed, kinetic energy, the energy of motion. Smash. The energy cashes out as splash, sound, and a little warmth. The books always balance. Nothing went missing. Killer detail. Kinetic energy goes up with speed squared. Double your speed, and you don't double the damage. You quadruple it. That's why fast crashes are so vicious. Energy comes from work. Force times distance. Push this wall as hard as you want. It doesn't move. Distance 0. So your work is officially 0. Your arms scream otherwise. Physics shrugs. No distance, no work. Sorry. Now the volunteer gets ambitious. He builds a free energy machine. Infinite power. A magnet chasing a carrot. What could go wrong? Half a turn. Dead. The energy didn't vanish. It leaked out as heat. Congrats, buddy. You built a heater. Free energy machines aren't uninvented. They're forbidden. You can't get more out than you put in. The cosmic accountant says no. So when you burn energy, you destroy 0 of it. This morning's calories are still in the universe, just smeared into the air as warmth, too spread out to gather back. Energy is never lost. Beautiful. But it left one giant question open. It says the total never changes. Never which direction things go. Next rulebook, thermodynamics. The physics of heat, mess, and why you can't uncool your coffee. Watch. Our guy's coffee goes lukewarm. He tries to scoop the warmth back in. It'll never work. And the reason is one of the deepest ideas in science. Heat only ever flows hot to cold, never the reverse on its own. Temperature is just how fast the atoms jiggle. Your coffee surrenders its jiggle to the room and never gets it back. The reason has a name, entropy. And it's not really mess. It's counting. There are astronomically more ways to be lukewarm and mixed than hot and separate. So spread out wins. Not because nature is lazy, because there are just way more ways to do it. Second law, entropy of a closed system never goes down. That's why you can scramble an egg but never unscramble it. Same energy, one direction only. And the mind blow, the basic laws run fine backwards. The only reason time has a direction, the only reason you remember yesterday, not tomorrow, is entropy spreading out. Time has an arrow only because the universe started absurdly tidy and has been unspreading ever since. The arrow of time is the Big Bang's leftover neatness running out. Hold on, you say. My fridge makes things colder. Doesn't that beat entropy? Great question. No, the fridge isn't a closed system. It lowers the entropy inside by dumping even more out the back as heat. The room's total mess goes up. You can only move the books around. Same with you. You're an ordered living thing, paid for by dumping huge heat into your surroundings. Life doesn't break the law. It rents order and pays in heat. Run it to the end and everything reaches the same boring temperature. No gradients, no work possible. Physicists call it heat death. Cheery. So we've got motion, gravity, energy, times arrow. But that was all things touching things. The next rulebook handles forces that reach across empty space. And it secretly runs your whole life. Electromagnetism. The force you're using right now to not fall through your chair. Here's what broke Newton. A magnet drags a paperclip with nothing in between. No touch, no string. Newton only knew contact forces. This was witchcraft. The fix was a wild idea. The field. An invisible influence filling space itself. The magnet doesn't grab, it warps the field, and the clip rolls downhill in it. First, charge. Plus and minus. Likes shove apart, opposites snap together, and notice the rule has the exact same shape as Newton's gravity. Same detective, new crime scene. Now the volunteer's favorite betrayal. He leans on a solid wall. Zoom in. His hand is electrons, the wall is electrons, and they repel before they ever meet. He's hovering on a force field a nanometer thick. So that high five? Pure force field. You've never actually touched anything. Not your phone, not a hug, ever. Atoms are basically empty. Solidity is just electrons saying no. One guy, Maxwell, wrote the whole rulebook in 4 equations. Plain English. Charges make electric fields. And you can never get a lone magnetic pole. Cut a magnet in half and each piece still has a north and a south. Then the bombshell. A changing magnetic field makes electricity. Wiggle a magnet by a wire and current flows. And the mirror image. A changing electric field makes magnetism. They make each other. Flowing electrons are current. The push behind them is voltage. That one trick is nearly every power plant on Earth. Coal, gas, nuclear, hydro, wind. All fancy ways to spin a magnet past a coil. Your whole grid is that wiggle. And the jaw dropper. Electric makes magnetic makes electric, leapfrogging through space forever. That self-feeding wave is light. Light is electromagnetism walking. Radio, microwaves, X-rays, the Wi-Fi soaking your room right now. All the same thing as visible light. You see a tiny sliver. The rest is invisible and everywhere, and it all moves at one exact speed, 299,790, 2,458 meters per second. Remember that number. It's about to break the entire rulebook. Newton said speeds add. Run toward a ball, it hits you faster. So our guy sprints after a light beam, expecting to catch up. Common sense, right? Nope. No matter how fast he runs, the light races away at the exact same speed. People measured this. Michelson and Morley, 1887. And light refuses to play by Newton's rules. Everyone, however they move, measures light at the same speed. To keep that true, something else has to give. And what gives is reality itself. That's where Newton's whole 400-year rulebook finally shatters. Crack number 1, the big one. Enter a patent clerk with terrible hair, Einstein. To keep light speed fixed for everyone, the universe bends your clock and your ruler. Time and space themselves stretch and squish. Not the rigid backdrop you thought. So our guy rockets off near light speed and comes back. And his twin is an old man. The traveler aged slower. Not a trick. Real and measured. We watch it constantly. Particles called muons, made high in the atmosphere, should decay before reaching us. They don't, because at near light speed, their clock runs slow. Time dilation, measured daily. And you trust this every day. GPS satellites run on clocks that tick differently than yours, by 38 millionths of a second a day. Ignore Einstein, and your map drifts 10 kilometers off. Every restaurant you find, you're trusting relativity. Then Einstein dropped the real bomb. Gravity isn't a force at all. Sorry, Newton. Mass bends space-time, and things follow the straightest path through the bent fabric. Here's the picture. 2 people on the equator both walk perfectly straight north. They never turn. Yet they meet at the pole. Not because they steered, but because the ground is curved. That's gravity. It's why an astronaut in orbit feels weightless, not escaping gravity, just following the straight line. You feel weight only because the ground shoves you off that path. And the famous one, E equals mc squared. Mass and energy are the same stuff in two outfits, and c squared is a monster number, so a sliver of mass equals a mountain of energy. 1 single gram of mass, fully converted, is roughly a nuclear bomb's worth of energy. Mass is just energy sitting very, very still. Hold that thought. So Newton's rulebook didn't die. It became the slow, weak gravity special case. Einstein zoomed out and conquered the huge. But relativity is silent on what stuff actually is up close. To answer that, we zoom in, past where Einstein's smooth spacetime even makes sense. Nuclear and particle physics. The question is dead simple. What is stuff all the way down? Our volunteer grabs scissors. Cut an atom. You get a nucleus and electrons. Atom means uncuttable, by the way. They were wrong. Cut the proton. 3 quarks, held by the strongest force in nature. No matter how hard he yanks, he can never pull 1 quark out alone. The glue snaps back, always. Count the protons and you've named the element. Change the neutrons and you get a heavier twin, an isotope. Pack in too many and the nucleus gets unstable and spits out radiation. Half-life is how long until half of it has fizzled away. This is the bottom of the box, the standard model. Everything you've touched is built from up quarks, down quarks, and electrons. Plus a famous one, the Higgs, confirmed at CERN in 2012. That gives the tiny fundamental particles their mass. But here's the twist. Almost all of your mass isn't those particles. It's the energy locked up holding them together, energy you can weigh. EMC2 again. And remember, basically empty? Scale an atom up to a stadium and the nucleus, holding almost all the mass, is a marble at the center. You're standing on the empty bleachers. Now cash in EMC2. The sun shines by fusing hydrogen into helium, deleting 4 million tons of its own mass every second. That sunlight on your face? You're warmed by destroyed matter. 2 ways to release it. Fission splits a heavy nucleus, reactors, and atomic bombs. Fusion joins light ones, the sun and hydrogen bombs. Opposites, both pay out energy. And where's the energy from? The products weigh a tiny bit less than what you started with. That missing mass became energy. The massed effect. EIRMC2 in the flesh. So when our guy snips the wrong nucleus, boop. Tiny mushroom cloud. Eyebrows, gone. Hair, standing. Lesson, learned. Also, slightly radioactive now. We don't recommend. So we've got the particles. But one tiny question wrecks everything we just drew. How does an electron even sit in an atom without falling in? Answer that, and the whole everyday rulebook breaks. Crack number 2, quantum mechanics. The spookiest, most accurate rulebook we own. And it starts with a disaster. Classical physics says an orbiting electron should spiral into the nucleus, and the atom should self-destruct in about 10 trillionths of a second. Every atom. Instantly. So much for electrons looping like planets, and it gets worse. The old rules said a glowing campfire should fire out infinite energy. Your fireplace should be a death ray. It is not. The math was clearly badly broken. Planck's desperate fix in 1900, what if energy isn't a smooth ramp but a staircase? It only comes in fixed lumps. Suddenly the math worked. Reality is pixelated. That's why the atom survives. The electron is stuck on an energy ladder with a bottom rung it physically cannot fall below. Ugh, the basement's sold out. Guess I live forever. That's why you exist. Einstein won his Nobel, not for relativity, for proving light comes in packets too. Photons. Dim blue light kicks electrons loose, bright red light can't. It's the color, not the brightness. Light is lumpy. Now the truly weird part. Ask where a quantum thing is and you don't get a spot. You get a cloud of probabilities. Not we don't know. It has no definite position until measured. Schrödinger's equation describes that cloud perfectly. Smooth and predictable. But the cloud only tells you odds. The actual result, when you measure, is random. The universe rolls dice. And there's a hard wall. Heisenberg's uncertainty. Pin down exactly where something is, and how fast it's going goes blurry. Not because your ruler's bad, because nature has no sharper answer. Then the experiment that breaks brains. Fire. 1 photon at a time through 2 slits. Over many shots, stripes build up, an interference pattern. Each photon interfered with itself, traveling as a spread out wave that samples both slits. But the second you peek to see which slit it took, the wave collapses, the stripes vanish, it picks one. Measuring changes the answer. And measuring just means any interaction. No conscious human required, despite what the internet says. Our volunteer hates this. He's smeared across 2 chairs, until you look, and he snaps to 1. Can a guy not be a probability cloud in peace? Apparently not. So now physics owns 2 flawless rulebooks. Relativity runs the huge. Stars, gravity, your GPS. Quantum runs the tiny. Atoms, lasers, your phone, each right to a dozen decimal places. And yet, even both together still only explain a sliver of what's out there. There's just one problem. Ask them about the same thing and they scream completely different answers and refuse to talk. Physics' two best detectives, and they hate each other. Which brings us, finally, to crack number 3. The one still open right now. Promotion time for our volunteer. He's a detective now. Where do the two rulebooks actually fight? You need both only in one place. Something hugely heavy and tinier than an atom. The center of a black hole. Or the Big Bang. Smush them together there, and the math doesn't struggle. It explodes. The equations spit out infinity and die. Gravity refuses to go quantum. Nobody's fixed it. Not Einstein, not anyone, not yet. The missing rulebook has a name we can't fill in. Quantum gravity. String theory, loop quantum gravity. Guesses, all unconfirmed today. The page is blank. And it gets funnier. Add up everything those rulebooks do explain. Every star, planet, person, atom, that's about 5% of the universe. 5. The other 95%, about 27% is dark matter, invisible mass holding galaxies together. About 68% is dark energy, a push speeding the universe's expansion, UP. Our official peer-reviewed name for both. We have no idea. Look up tonight. You're made of the rare leftover stuff. Every galaxy you see is gripped by matter you'll never touch, drifting apart on energy nobody can name. We're a minority living inside a mystery. And our poor volunteer, beaten, split, smeared, irradiated, finally asks the only question that matters. Okay, what am I? Really? All the way down. And for the first time all video, physics shrugs. Relativity says one thing. Quantum says another. 95% of him, of everything, is unidentified. He doesn't get closure, so he doesn't get answers. He gets a promotion, the clipboard, the lab coat. From crash test dummy to detective. And then he points at you, because that's the real ending. The textbook lied. Physics isn't finished. It's a 400-year detective story where the detective just realized he can't see 95% of the room. Newton wrote clockwork. Energy found the ledger. Thermo found time's arrow. Maxwell made light. Einstein bent space. The atom split into a zoo. Quantum made it a cloud of odds. And everyone was born from a crack in the last. The biggest case in physics is still wide open. The crack is right there, glowing. Somebody's going to walk through it. Maybe it's the next great detective. Maybe it's some bored stickman with a clipboard. Maybe it's you. He takes one brave step toward the unknown, and his leg goes quantum. Half of him is here. Half is probably. So which crack would you walk through? The black hole or the 95%? Tell me below. I'll draw the one that wins.